Welcome down Home Crypto. I'm Serenity, and in this episode, we're going to do the ultimate deep dive. We're going to go deeper than smart contracts. We're going to go deeper than blockchain. We're going to go deeper even than Bitcoin. We're going to go to the very heart and foundation that must exist for this entire crypto world to exist. So what is that, you might ask? Well, it's power. That's right, electricity. Without that, none of this world exists. But first, do me a huge favor. Take a moment, like this video, subscribe to the channel, click that bell notification so you're alerted every time I upload a new video, because some of this information can be time sensitive. Most importantly, as always, do me a huge favor. Go out into the world, tell somebody that doesn't know this world exists, let them know. They don't have to be tech savvy. They don't have to have a college degree. They don't even have to be rich. They simply have to have a desire to change their life and the courage to follow that dream. And they too can join us on this great adventure. So you're probably asking me, why am I doing a crypto video on power? Well, it's simple. Right now we are in a very unique time. We're in a bear market where a lot of these machines that were mining these crypto coins and were very profitable just a few months ago are no longer profitable because the power stayed the same or even went up. But now the earnings of the machines have dropped to where they're either neck and neck or even losing money day by day. So a lot of these mining machines have been unplugged and sold on eBay and different marketplace, things like that, for fraction of the cost originally. I mean, some of these machines that were a couple $1,000s 6 months ago are now a few $100s today. So there's a few of us out there, speculative miners like myself, who's been picking up these machines, plugging them in, starting to earn the coins with the concept in our minds that yes, the coins we're earning right now might be losing a little money, but you know what? Their all-time high or even their mid-range price was up here. So if I can mine them and collect them now, then when that price does go up and we hit the next bull market, I'm going to have a stockpile. Yes, I'm paying for it today, but that's what speculative mining is. It's mining today for earnings tomorrow. So what kind of machines am I talking about here? Well, I'm talking about an ASIC miner, an application-specific integrated circuit. And an ASIC miner is something similar to this guy right here. So this machine does nothing but runs all day like a small jet engine, makes a lot of noise, a lot of heat, and uses a lot of power. Power supply that connects this guy looks like this. A whole bunch of cables, a whole bunch of connectors. Now once you plug these guys in, not only do you have a whole lot of heat, a lot of noise, most importantly, you have a ton of power being consumed. I'm going to make this as simple and direct as I possibly can. Do not proceed. Hire an electrician. Do not start jumping in and modifying your panel box and your wiring to accommodate for all these machines and the load. Get somebody out there like myself, a journeyman electrician, who's licensed and registered in that state, knows the codes, knows the calculations, and can absolutely set you up so that you, your property, and your machinery are all safe and here to see another day. But some of you are not going to listen to this. Some of you are going to dive in. And you know what? I can't stop you. What I can do is try to keep you safe. So understand this video is not a step-by-step guide on how to do this. This is the steps and processes I would go through in my world for my machines that I'm going to share with you to hopefully keep you safe. And the one thing I want to stress more than anything here, people, is the same thing I stress to my crew every day at work before we start, which is electricity kills. There is no lights, there is no smoke, there is no warning. If you touch something or do something wrong, you could simply be dead. Game over. So, think long and hard before you decide to proceed. And if you do, I'm going to share the information I go through for my equipment. What you choose to do from there is up to you. Now, the first thing I have to do is figure out how much is each of the machines that I'm going to connect, what's its load? Because I don't want to put too many machines on one circuit and end up blowing the breaker or overloading the circuit, possibly melting the wire, causing all kinds of damage internally, whether to the machine or to the home itself. Because, yeah, hot wires, not a good thing. So I need to know that amperage load. Now, there's a couple different ways that I go about this. One of the easiest is I own an M9 amp meter, which I bought off Amazon for like 15, 18 bucks. And what I can do is simply plug that into my power supply, and then plug my cord into there, let it ramp up, and once it hits full operating speeds, then I can look at the display and find out exactly how many amps that's drawing, check back on it from time to time, get an average, and know that pretty much what to expect the highs and the lows, okay? Now, that's, of course, if I already have the circuitry and everything set up. Now, if I don't, and I'm trying to plan an initial circuit I'm going to add to my garage, because I'm going to put another PDU unit in that display cage that you saw with all the machines that are insane, then I can do it the other way around, which is running the load calculations. So I'm going to show you how I go about that. Now, in this example I'm going to go through, this would be to calculate out the amperage load on my L3 Plus miner. So I know by specs it should be 660 watts. And if I go in here to the auto tuning configuration, that's exactly what I've got it set for. 504 megahash a second at 660 watts. But my experience has told me that's not accurate. That's a ballpark. So to get the real numbers, what I'm looking for is I want to go into the miner status. Now this one is running, and every 10 seconds it's going to update this screen, but it's going to give me real true information. And if you go down here to the miner, it's going to tell me my hashboard wattage, most importantly, my total consumption, 695 watts for this machine. So let's go in and do the calculation on that. So we're going to pull up our Ohms Law wheel, and we're going to open our calculator. Now, the way this operates is with Ohms Law, as long as I have any two known variables, I can solve for the third. So I have to have either power, current, resistance, or voltage. And I have to have two of those to find the third. Well, we're looking for amperage or current. So current is represented by I. So right here is what we're looking for. These are my three formulas I can use. Now we know that E is the voltage, and P is the power, and R is the resistance. So the power is our wattage. Well, we know that. That's 695. And E is our voltage. Well, we know that because we're running on a 240 volt circuit is what we're going to wire this up as. So all we do is go 695 divided by 240, which is our P over E, is going to give us our amperage. So that tells us this machine is running at 2.895 amps currently. Now, when I'm doing this and I'm planning a circuit out, I always like to give myself an extra little leeway. So I'm going to say this is running at 3 amps. I'm going to round it up just to give myself that extra bit. Now that I know each machine is running 3 amps, I have to decide what kind of circuit I'm going to build depending on how many machines I have. So I currently have 9 machines, but I'm probably going to add more. So let's just do 9 for now and see what we end up with. So 9 times 3 gives us 27 amps. Now I never want to push my circuit to the breaking point. So I could build one 30 amp circuit and get all these machines on there, but man, that's awful close. So I would rather build 2 20 amp circuits to give myself the leeway. So if I go 5 times 3, it's going to give me 15 amps on one, and then 4 times 3 is going to give me 12 amps on the other. Now, that's much more reasonable compared to what I feel safe at. So instead of one 30 amp circuit that I'm right at the breaking point, I'm going to do 2 20 amps and split them 5 and 4. And that'll even give me room to add one more machine to this down the line. So the next piece moving up the line for my ASIC miner is what's it going to plug into? And that's a PDU, or power distribution unit. Now, there's a lot of variables within that. The first thing I have to figure out is what kind of cord do I want to use? Do I want to use a C13 to C14 cord, which looks like this guy? And it's just the male and the female, the same thing on the back of the computer itself. Or do I want to see a C13 to a normal outlet? Well, I don't like these guys because I know if I make a 240 volt circuit and it can accommodate a standard plug, there is a possibility that somebody may decide they want to plug in an extension cord to it. And that would fry pretty much whatever they plug into it. So you know what? I'm going to stick with a C13, C14 system because that adds a level of safety that nobody can use unless they use the right cord for it. So the next part is what kind of PDU do I want? So we're going to jump over here to Amazon, and I did a search of PDU 240 volt for a 20 amp circuit because that's what I decided to design for this. And I'm looking for the C13, C14 connections. I know I need at least 5 per PDU unit because that's how many devices we're going to plug in. And there's a lot of variations. Then we start looking at it has a metering system or monitoring or surge arrestor or inline breaker system. A lot of different things, as well as a C19 connector like this guy right here, which I don't need that because just with the 5 machines I've got, that's going to fill up all the outlets. So I just need 5, and I'm not seeing just 5. So some of the simplest ones, like this guy right here. He's a straight up C19 for the power and a row of C13, C14s for the inlets. So that's pretty much good. Now, it doesn't have an inline surge arrestor. Kind of wish it did. But when I start hitting the price range of those guys of $300 and $400, I'm doing this on a pretty frugal budget. So you know what? I'm going to get the $75 one because I know my load calcs are good. I know my circuit's going to be good. And I'm not too worried. I don't have too many issues here in Idaho where I'm at as far as lightning or surges or things like that. Pretty solid. Still, if I was going to plug in a regular computer, I would absolutely get one that had a surge arrestor and pay a little bit more to protect those electronic devices. So that's personal choice. That's just what I'm going because this is only going to be used for ASIC miners. So after the power distribution unit, the next stop is the wire in the wall. And that's going to go from the outlet the PDU plugs into all the way to the end of the breaker. Now, being I did this in residential in my own garage, I used NM cable, or what we call Romex. And that's basically copper conductors inside a plastic sheathing. And it's already set, and this is what most of residential here in the US are set on. Now, if I was doing commercial, or if this was going to be exposed for any length of distance, like on the outside of the garage or something like that, I would have run like a THHN conductor through a metal conduit, something to protect it from damage, things like that. But since this was in the wall and under the floor, totally protected, so I just went with Romex cable, called it a day. Now, with gauges of wire, it's kind of confusing because as the wire size goes up, the gauge goes down. What do I mean by that? Well, think of it like a shotgun shell if you know how that works. So the smaller the number, the bigger the wire is how this works. So to give you an idea, this is a 14 gauge. And put that next to a 12 gauge. And put that next to a 10 gauge. Try and turn that around there. So as you can see, the 14 is the smallest, goes up to the 12, then up to the 10. So now with all the PD units that I've been looking at, they're pretty much 20 or 30 amps. Now, a 12 gauge wire is rated for 20 amps. And a 10 gauge wire is rated for 30 amps. So these are the really only two that I've needed to look at. And I'm just running with 12.2 because I'm running 3 20 amp PDUs. So I utilize my 12.2. Now you might be asking, well, if that's the same thing running in my kitchen or my bathroom, how is that operating on a 240 volt circuit? Well, the truth is the wire here in the United States is all rated for 600 volts. So it's okay. It's made to handle it. And the big trick here is normally on a 120 volt circuit, you've got your hot and you've got your neutral, and that's how they connect in the panel box. But what we need is 120 volts on both. So we really have to watch that color coding aspect. And so to make this a 240 volt, the special thing I had to do is change the color of the neutral wire to meet the code. So I take a red marker and I just put a little slit in it, and then I run around and I paint the thing red because we have to permanently color it a different color. So now what we end up with is, there we go, a black wire and a red wire, showing that signifies that both wires are hot. Neither one is a neutral, neither one is safe to touch. And that's for any future electricians come in like me. Not only is that building code, but that's just a way to keep myself safe and the future guy safe as well. So that's the wire I'm going to run with, and that's how I'm going to mark it and get it prepped. So the next stop is panel box. So to understand how the breakers are going to work and how I'm going to connect this, I want to explain a little bit about a panel box. So this is your standard residential single-phase panel box. It's got your main disconnect breaker here. It's got your neutral bus bar here. And it's got your ground bus bar over here. And then you have your two phase plates, which will connect here and run down this guy. And this phase plate will have 120 volts. Your next one will connect here and runs down this way, and it has 120 volts on it. Now, the critical thing to understand, and this is really confusing for a lot of people, is you have two lines supplying 120 volts, but they're out of phase. Now, if you don't know, electricity operates on a sine wave. Okay, so it's basically a sine wave, just looks like a wave in the ocean. Well, they operate on different wavelengths. So same 60 hertz frequency, but they're timed differently. They're out of phase, technically. So as the first wave is at its peak, the wave right behind it is actually coming at a zero. So they kind of coincide, they're opposite time, not exact opposite, but they're timed differently so that when one is at peak, the other is at zero. And when this one's at zero, this one's at peak. And they switch back and forth like that. So when you're talking about phase voltage, you're talking about the voltage variation across these two. Now, if they were on the exact same phase or wavelength, then when you measured across the two bars on a meter, that would give you a zero voltage because there's no variation in the voltage. They're both up and down at exactly the same time, right? But since one is up and one is down, there's always a variation between the two. And so that's where you get 120 top, 120 down, which gives you a total of 240 combined phase variation. Okay? I know that's really confusing, but I'll explain it more in the breakers. So let's go look at those real quick. Now, I don't know if you've ever walked down the electrical aisle at your local Home Depot and just looked at how many variations of breakers, but it's mind-boggling. There are so many variations from manufacturer, from the type, from the amperage rating, the style, all the different features on it. And it really is critical to know exactly what I'm doing when I go to pick my breaker. So we're going to run through these real quick. So a standard single pole breaker like this guy, this is a 15 amp, and the number must always be stamped on the handle, the amperage rating. But it's a single space, single phase, which means this is going to put out 120 volts for one circuit. Okay? But this guy here has two handles, so that's got to be 240 volts, right? Well, no, it's not. And here's why. Because if you look at the contacts, it's still a single phase contact. So it's still only getting 120 volts from one phase. So even if you power it here and you put in two different wires, the phase voltage variation is still going to be 100, or it's actually going to be 0 volts because there's no variation across the two. So it's really kind of funky. You got 120 volts coming out of one, 120 out of the other, but it's the same 120 volts. So if you measure across looking for a variation, it doesn't exist. It'll come up as 0 volts. Okay, so even though it looks like a 240, it's not because it's still single phase. Now, then you got guys like this, which is also a single phase, but he's got two screws, but one handle. Now that's weird. Well, this is an arc fault breaker. So on this particular setup, I have to put the hot in one, the neutral in the other as marked, and then it has its own neutral wire to go out to my neutral bus bar. And this is solely to protect for arc faults, as well as, of course, the overcurrent and overload that's built in the standard of the breaker. Then you got guys like this, which this looks like a monstrosity, and it is. But it's a completely different configuration. Still single phase, still 120 volts, but it's a different style for a different manufacturer of panel box. So the panel box manufacturer is also critical because how it connects. But what I'm looking for, as we know, is a 20 amp, 240 volt, and we need a 2-pole breaker for 240 volts. So that brings me to this guy. Now, the big thing here, of course, is you got the two separate phases. So 120 volts here and 120 volts here, but it's going to hit the two opposing phase bars. Hence, there's that phase variation, giving you a total of 240 volts. Okay? Now, you can tell on this because the two arms are locked together. So if I hit just one side, it clicks both. And that's really critical to have. It's a safety issue, it's a code issue, but all the way around, that's one of the telltale signs. That's a 240 volt circuit. Okay? And then, of course, the numbers are stamped, but as you can see, that's a 30 amp breaker. That is not going to work. Even though it's the right manufacturer, it's the right size, voltage type, all that, the amperage is wrong. So what would happen if I took my 20 amp circuit and I put it on a 30 amp breaker? Well, as this guy heats up or a short circuit or something happens, this wire is going to melt before this guy trips because he's set for 30 amps. He's going to go critical at 20. So this is not going to work. So I have to get an actual 20 amp breaker just like this to go with my 20 amp circuit. This guy here, now he would fit if we built a 30 amp circuit on our 10 gauge wire. Absolutely. That's a perfect fit. But if I were to go and put this 12 on, really, really bad things happen. So knowing this information is critical. So I know going in, I need a 2-pole, 20 amp, 240 volt breaker. So the last part I have to take in consideration is the size of my service. Now, as I'm adding more amperage load onto my house, all that load is going to pass up and it's going to be combined with, the microwave and the range and the dryer and all that. And so the initial wires coming into my house or the service, I have to make sure it can handle the amps I'm going to load it up with. Now, most houses have a huge calculation you go through for laundry circuits and all this kind of stuff. And then they do the same thing. They plan their circuit that supplies the house. Now, if I exceed that excessively, I can actually cause the power company's wires to melt out there and cause a big problem for the actual power grid. So as you can see, there's a lot of parts that go into this, but I want to make sure to mention that because as I put more machines on my system, I have to really take into account all parts of the circuitry. So I hope this information has been helpful. I believe speculative mining is a great thing, and I think picking up these machines at this discounted price is an awesome idea if you believe the coin that it mines is going to go up. But I really want you guys to know this is what it takes to go through and do this job right. And there's even some information that I didn't include in here because it just starts getting too technical and crazy. But I tried to give you the gist so that you can really see that if you do get some of these miners, call an electrician. Because if something goes wrong, the money that you're going to spend now for an electrician to avoid that happening, imagine if you had to replace your home, or even worse, your life. You can't replace that. You can't buy that. Spend the money, get an electrician, get someone like me out there who knows all the ins and outs, and we can tell you exactly what it's going to take, and we can set this up right to protect your home, your family, and your life. So, thank you for your time. As always, I appreciate it. And once again, please like this video, subscribe to the channel, and share this information with somebody out there who might be endeavoring to do something like this, and let them know there's a lot to it. It's not just plug it in and go. So, thank you. Have a great night.